Okay, question number 5, the last question for this week. So this is from Doppler effect. Okay, one of the subtopic in chapter 10. Okay, so let's look at the situation of the question. Okay, we have a sound source which can produce a sound frequency of 300 hertz. Okay, so this is the frequency of the source. Okay, sound source move away from a stationary observer. Okay, so move away from the stationary observer. So stationary observer means that we have VO is equal to 0. The observer noticed that the frequency of the sound heard, so the frequency of the sound heard changes by 10 hertz. Okay, so we need to deduce a frequency of sound heard, or we call it as apparent frequency. So basically, this is our case of moving away. Okay, that is source that is moving away. Basically, when this is the case of moving away, our frequency apparent is low compared to the source of the frequency, meaning that you need to calculate the FA, that is equal to 300 minus 10 hertz, that is 290 hertz. So this frequency of the sound heard, because it changes by 10 hertz, so we need to do this calculation. So for the case of a stationary observer, we have formula for Doppler effect is equal to V plus minus, this is the general formula, VO over V plus minus Vs times the frequency of the source. So we can cancel out as our VO is equal to 0, so we don't have VO here. Because the sound heard is low, so the denominator here must be high, so we need to use plus. Then the equation, or the correct equation that we're supposed to use for this case is FA is equal to V over V plus Vs times Fs. Okay, and we want to find the speed of the sound source, meaning that we want to find Vs. Okay, so we want to find Vs. So substitute all the values we know. So 290, 340 over 340 plus Vs times 300. Okay, rearranging the equation using your mathematical knowledge, then you will get your Vs is equal to 11.72 meter per second.